Hello there, this is Miss Oy again. Today we want to look at 6E, solution of trigonometric equations. So trig equation over restricted domain. Firstly, identify the quadrants in which solution lie and find the first quadrant reference angle. We can call it reference angle, basic angle. Find other solutions using symmetrical properties. Right. So let's look at the first example, call it example 10. Solve 2 sine theta equal to 1 for theta greater or equal to 0, less than or equal to 2 pi. So method 1, there's a few methods. So let's look at the first method. The first thing is you take careful notes of the domain, because this tells us that we need to find all the possible solutions inside this domain. That's from 0 to 2 pi over one full resolution around the unit circle. Okay. All right. Step 2, make sine theta the subject. So our aim is to make sine theta the subject. So you isolate and make sine theta on its own and make use of ASTC, all signs, all positive, sine positive, tangent positive in the third quadrant, and cosine positive in the fourth quadrant. Step number 3, consider the sign. So take into consideration the sign given. So sign is positive, which means that we're looking at the first quadrant. So in this case, sine theta equal to half. That means that we're looking at first quadrant, quadrant 1 and quadrant 2, of course. Okay. All right. Step number 4. Do the quadrant angle, Q1 angle first. Sine theta equal to half. Theta is equal to pi on 6. So theta is basically the inverse sine of the given ratio, which is half. And you need to know your exact value here. Inverse sine of half is pi over 6. Okay, so we can draw that little diagram. Okay, so that angle theta, which is pi over 6 here. Okay, step number 5. Find the quadrant 2 angle by reflecting 30 into Q2. So instead of drawing that again, let's look at this side, theta. So that will be pi minus theta. This side is always pi minus theta. In our case, is pi minus pi over 6. If the question comes in radian, we must return answer back in radian. Don't change that to degree. So we have pi minus pi and 6, which give you 5 pi and 6. So therefore, the solution for theta is pi and 6, 5 pi on 6. So sine pi and 6 equal to half. Sine 5 pi and 6 is also equal to half. All right. Okay, example 11. Same questions, but this time we want to use solve on CAS calculator. So take your CAS calculator. So let's go to Math 3 and let's use solve. So type 2 sine x equal to 1 comma x. Now, very important, make sure you have conditions. Here we can see that in Math 3 we can find the stroke, which is the conditions. X greater or equal to 0, less than or equal to 2 pi. What will happen is that if you don't put the conditions, your calculator will give you a general solutions. The other thing, important thing is take note of the standard. At the start, I forgot to put standard, so therefore it returned a decimal. And you do not give decimal places unless otherwise stated. So always leave your answer in the exact form. So I change the standard. Another important point to take note is the radian mode. So you can see here theta is in radian mode. So I got to make sure that that's in radian mode. Yeah, if you don't want to use x, you can use back theta. But when you write whether you use x or theta in your calculator, make sure that if the question asks for theta, you return is theta here. So theta is equal to pi over 6 and 5 pi on 6. That's all for this example. Okay, how does it look like in terms of graphing? So I graph y equal to 2 sine theta. So remember we are solving 2 sine x, 2 sine theta equal to 1. So basically you graph y equal to 2 sine x and y equal to 1. So we are finding the point of intersection between these two graphs. That's what we're interested in, and this point as well. So on our CAS, we find that point intersections, go to analysis and GSolve, okay, analysis, and go into GSolve, find GSolve and intersect. All right, now it gave me 0.524 round to 3 decimal place, and the other answer is 2.618 round to 3 decimal place. These are just the pi and 6 and 5 pi and 6 we got earlier. The CAS calculator unfortunately is limited in that it won't give you exact results. So if the question did not ask for decimal places, the place to go to is there. Just go to the main and use a solve to find. All right, example 13. Find two values of x. First one is a sine x equal to negative 0.3 with x lies between 0 to 2 pi inclusive of the two endpoints. Okay, again, I use CAS. Solve sine x equal to 0.3, put a given side. That's given. That's a domain given. And the calculator spit up two answers. One is x equal to 3.446 and so on, and 5.97849 and so on. Okay, now in exam, they will ask you to round to certain decimal. So make sure that you follow the instruction closely that's given in the questions. So for part A, make sure your CAS calculator is in radian mode because it's in radian. For part B, you notice that x degree, so that is in degree. Can you see here when it's in radian mode, you would just see sine x without the unit here. It's understood it's in radian mode. It's in degree, we could see cos x degree. So what you need to do now is for part B, you got to change that to degree. Okay, and again you follow the same thing, cos x degree equal to, because you put degree already, you don't have to put cos x degree, just cos x equal to negative 0.7 comma x. And the conditions, we're interested in x lies between 0 to 360. Any solution is inside that domain. By the way, there's an error here. I should put less than equal. Okay. All right. So which give us two answers, 134.43 degree, and the other one is 225.57 degree. Okay. Again, we put that in decimal. All right, let's look at example 14. Find all values of theta between 0 and 360, for which the first one is cos theta degree equal to root 3 on 2. And all right, let's start with the first one first. So let's do first one, cos theta is equal to root 3 on 2. Now you begin to think, what's the reference angle in the first quadrant? In other words, my basic angle here. Or what's my base angle? Some people call it base angle. So my base angle will be inverse of this ratio, inverse cos of root 3 on 2. Okay, so the base angle, the basic angle, whatever you want to call that, it is 30 degree. The reason why I write 30 degree, because here is in degree. Okay, theta is between 0 degree to 360. Okay, now you need to remember this by heart. If you are not sure, always remember that triangle sine pi over 6 is equal to half. So that's theta 1, 2, all right, and that is root 3. So I want to find the ratio is root 3 on 2, okay? So basically cos theta is root 3 on 2. What is that angle? That angle is pi over 6, which is 30 degree here. All right, let me write now. Nice, write it down. Nice. Okay. All right, so now that we got the base angle or the basic angle we have got here, so we know that theta degree lies in the first or the fourth quadrant because cosine is positive. So cos is positive in this side, first quadrant, and the fourth quadrant. So the first angle we got here is 30 degrees. Going around all the way here, you get 360 minus 30, which is 330 degrees. Okay, so draw that mini diagram. It will help you. So theta is 30 or 330 degrees. And have we answered the questions? That's it, because we only need to know one cycle solutions, one revolutions. Okay, let's look at B. Sine theta is -half, so find the base angle first. So the base angle for that is theta is equal to inverse sine. Ignore the negative, just go for the first quadrant solution, which is our base angle or reference angle. So we know that inverse sine of half is pi over 6. That's the base angle here. But here sine theta is negative. So when is sine negative? It is in the third and the fourth quadrant. So that's what we're interested in, third and fourth. The y value, sine is always referred to the y coordinate. So it's negative in the third and the fourth quadrant. Okay. So our base angle or the basic angle is 30 degrees. Okay, pi and 6, which is of course the same as saying 30 degrees. Okay, so now we need to find, here is 180 plus 30, and then 360 minus 30. So the solution set will be 210 or 330 degrees. 210 or 330. All right, let's look at C. Again, firstly, isolate cos theta on its own. So cos theta will be equal to 1 and root 2. Again, find the reference angle or the base angle or the basic angle. So basically, we're interested in theta is equal to inverse cos of 1 and root 2. Now, that has got to do with these types of triangle. So remember, tangent pi and 4. Oops. That's 1, root 2 here. Okay, so cos what angle is 1 and root 2? So the angle is pi over 4. Cosine pi and 4 is 1 and root 2. So theta is pi and 4, which is in terms of degree is 45 degrees. So please do answer the question. Check the unit given here. So 45 degrees. So now cos is positive in the first and the fourth quadrant. Okay, the first and the fourth quadrant. And so now the first answer will be 45. The second answer will be 360 minus 45. Remember that diagram, theta, pi minus theta, pi plus theta, and that's 2 pi minus theta. Or theta degree 180 minus theta degree 180 plus theta degree in the third quadrant, in the fourth quadrant 360 minus theta degree. Okay, so what we've got here, it will be 45 degree or 315 degree. Okay, clean up this. You guys can see the answers. All right, let's move on to the next part using calculator. And for those who are using TIA Inspire, this is what you do. Okay, look at the conditions come after the bracket. Now, using Casio ClassPad, which is our calculator, cos x equal to root 3 on 2. Don't forget the conditions, comma x. That will give you the answers. All right, so ensure your calculator is in degree mode. That's very important instructions. Okay. All right, solving equation of the form a sine nt equal to b and a cos nt equal to b. So now we are solving equations that involve dilation factor. So we can see here there's dilation factor 1 on n from the y-axis and dilation factor e from the x-axis. two methods we'll look at here. Method number one is I just find the two solutions in a cycle first. And then I look at the periods of the functions, the actual period of the functions. Then you're going to add or subtract lots of period to the first two solutions. In method two, you adjust the domain to the given expressions in the argument of the function. And then you find all solutions to this expression. And then you solve each of these for x. So let's look at method one. But before that, I'm going to sketch this and to have an idea, to let you have an idea what are we actually solving. So I'm going to use my CAS calculator to find that. So I got y equal to sine 2x. And I'm only interested in a graph from negative pi to pi. So I'm just drawing the graph based on the restricted domain. And then I get y2, which is negative root 3 on 2. So basically what I'm looking for is the point of intersection between these two graphs. So if the question asks for decimal, I will go ahead and just use analysis and GSOLVE, and then I find the point of intersection. And we could see here that we're expecting 4 solutions, okay? Because it has gone through 2 cycles. How do we know that it's gone through 2 cycles? So you take pi. So I'm just going to show you how to find how many solutions inside. So you take pi minus pi. So within here, within this domain, there is 2 pi units. You divide by the period. The period actually for this question is actually 2 pi on 2, which is pi. So 2 pi divided by 2, which is, 2 pi divided by pi, which is 2. So in other words, it has gone through 2 cycles. So every cycle is 2 answers. 2 cycles, I expect 4 solutions in here. All right, let's do that algebraically. Let's find the solutions algebraically here. So firstly, I'm going to write the question first. Negative root 3 over 2. So look for the base angle, which is inverse sine of root 3 on 2. Okay, so given the ratio, I can actually find the angle. What is inverse of root 3 on 2? It is pi over 3. Not sure? Always draw the special triangle out. That's pi on 6, 1, 2, and that's root 3. That's pi on 3. So root 3 on 2, opposite over hypotenuse. So the angle you're looking at is pi over 3 here. All right, but we're not interested in first quadrant because you're given that sine 2 theta is a negative. So therefore, you want the third and the fourth quadrant. So we want third and fourth quadrants. Okay, I just put Q. All right, so 2 theta, it is what the angle is equal to. Now, what is the third quadrant answer? Is pi plus theta. Our theta is pi over 3. So pi plus pi over 3. And then the fourth quadrant answer is your 2 pi minus pi over 3. So 2 pi minus pi over 3 here. So which give you 2 theta is equal to 4 pi on 3 and 5 pi on 3. So theta is equal to 4 pi on 6, 5 pi on 6. So you solve for firstly the first 2 solutions. Now you need to add because the solution will repeat itself every period so that we know that the period is pi. So P is pi. So right down here. So if I add pi to that answer, it's going to be outside the domain. If I add pi to 5 pi and 6, it's outside the domain. But I can take away pi from that answer. So therefore, the solutions that you're going to have here, it will be 4 pi minus pi, which is negative 2 pi on 6. 4 pi on 6 minus pi. So we get negative 2 pi on 6. 5 pi on 6 minus pi will get you negative pi over 6. So therefore, all the solutions set for theta will be, okay, in short, theta is equal to negative pi on 6, negative pi on 3, 4 pi on 6, which is 2 pi on 3, and 5 pi on 6. Okay. All right. Next, same questions, but we're going to look at the second method. So in the second method, I adjust that domain. So that's theta lies between that. So I'm going to adjust that to 2 theta. So that will become negative 2 pi to 2 pi. Okay, this method can be easy, but it can be more complex if that involve translations and so on. All right, so I adjust the domain. Again, same method. I go for my base angle, which is inverse sine of root 3 on 2, and which already know from the previous, it is pi over 3. So therefore, I will start with 2 theta. The angle is equal to, okay, same deal, same story. We are interested in this third and fourth quadrant because of the negative. So we know that that will be, my first angle will be that answers. So 2 theta is equal to pi plus pi over 3, which is equal to 4 pi and 3. My second answer is 2 pi minus pi and 3, which obviously 5 pi and 3. Now I'm going to add like what you usually do, 2 pi. The normal period is 2 pi. So it's like treating this like a theta, big theta. And of course, my big theta is 2 small theta, okay? Like that, okay? All right. Or call the x, no confusions. So I'm going to add 2 pi to that, so which give me, adding 2 pi mean adding 6 pi on 3, so which give you 10 pi over 3. Now, is this over? Is that over that already? So if I add 2 pi to that, actually it's exceed that 2 pi. So instead of adding, again, I can't add, but I can minus. So I'm going to minus 2 pi. So in other words, I take away minus 6 pi and 3, which give you negative 2 pi over 3. Then what you do next is you also take away 2 pi from here, which is minus pi over 3. Now only I do the divide. That's 2 theta. So theta will be 4 pi on 6, 5 pi on 6, negative 2 pi on 6, because it times everywhere by half to get rid of 2. So negative pi over 6. So theta will be 2 pi on 3, 5 pi on 6, negative pi on 3, and negative pi on 6. So that is our full solutions. So 2 different methods, and we get the same answer. All right, example 16. So pause the video, have a go again, and then when you finish, return. All right, welcome back. So now we are given fx equal to 0. So what are we looking for? We're actually looking for, if this is a graph, we're actually looking for the x-intercept. So the method here is we're going to isolate sine. So sine 2 x minus pi over 3 is equal to, bring all the numbers to that side, negative root 3 over 2. All right, as before, we look for the basic angle of the inverse sine of the ratio. So what would that be? Inverse sine of root 3 on 2, which is equal to pi over 3. Okay, So next, take into consideration it is negative that we are interested. So think of which quadrant will be our solution. So it's in the third and the fourth quadrant. So as before, third quadrant, pi plus pi and 3, so which give you 4 pi and 3. Okay, and the other answer would be 2 pi minus pi and 3, so which give you 5 pi and 3. All right, so therefore, this angle, which is 2x minus pi and 3, is equal to 4 pi and 3 and 5 pi and 3, third and fourth quadrant. Now what we're interested is we actually want to find x. So firstly times half everywhere, which is 4 pi and 6, and then 5 pi and 6. All right, and then you add pi and 3 on both sides. So adding pi and 3 means adding 2 pi and 6, so that will give me 6 pi and 6, which is pi. Adding 5 pi and 6 to 2 pi and 6, that will be 7 pi over 6. So this is a solution for one cycle, the first cycle. All right, so what are the other solutions? We're going to add or subtract the period. In this case, the period here is pi. So the period here is 2 pi divided by pi. Sorry, 2 pi divided by 2. I'm thinking of the answers. So 2 pi divided by 2, which is pi. Okay, so how many cycles that's inside that domain? We can see here is 3 cycles. If you're not sure, the number of cycles is equal to, take the top end of the domain, take away the minimum value of the domain, divided by the period, which give you 3 cycles. So we expect 6 solutions inside here. So therefore, all the solutions are pi. Okay, if I add pi to that answer, that will give me 2 pi. Check whether it's inside the domain. Yes, it's inside. If I add further, that will be going to be outside the domain. But now I'm going to take away pi, which give me 0. Take away pi again, that will give me negative pi. All right, that's okay. I can't minus another pi. That'll be outside the domain. So now the next answer will be 7 pi over 6. If you add pi to that, that's going to give you 13 pi and 6, which is actually outside the domain because the domain is 2 pi, which is 12 pi and 6. Now don't forget, we can also minus 7 pi and 6. If we minus 6 pi and 6, that will give me pi and 6. And then add minus another pi from the answer, it's negative 5 pi over 6. All right. Yeah. Is it negative 5 pi and 6? So you minus pi. So if I take away another pi, that will be outside that domain already. Okay. So therefore, in short, my answer is negative pi, negative 5 pi on 6, 0, pi, 6 pi on 6, no, 7 pi on 6, and 2 pi. Okay, I think that's all. And you can now do exercise 6E, and don't forget to go to OneNotes to check is there any exit tickets for this exercise. All right, thank you for listening, and we'll see you again. I'll see you again in exercise 6F.